So today we're going to stay and we're going to go through the 2013 Pure Mathematics Unit 1 Paper 2. So the question says, let P and Q be two propositions. Construct a truth table for P implies Q and not of P and Q. So to do a truth table, all right, question 1, we're going to do this truth table. So first thing, you draw a little table, and you notice that you only have two variables P and Q, so you can just draw a box like this. All right. We only need P and Q. Then we're going to need the results for P implies Q. All right, this should be fine. All right, that should be enough. Yeah, that should take care of it. So again, we know variables is P and Q. Then of course we need the truth table for P implies Q. Then them asks for not P, the not of P and Q. So we're gonna need, before we can construct the truth table for not of P and Q, we need P and Q first. So come in, let's work through all of this. So first thing, you write down the true, true, false, false. You have two true, then two false. Then you're gonna have true, false, true, false. And that covers all the four different possibilities in the truth table. Now that we cover all four possibilities, P implies Q, it is only false whenever the antecedent is true but the consequent is false. All right, so the only time it's going to be false is right here. Everywhere else is going to be true. P and Q now. For P and Q is true when both P and Q are true. So this is the only time when P and Q is true. Everywhere else is false. All right, so good. Then when you need the negation of P and Q, the negation of P and Q is going to be, you negate this column result to get false, true, true, true. And that's finished. All right, so this is part I, and this is part II. That's all I wanted. Now let's go ahead and look at part 2 now. This is A. We need to look at part B. Now let's look at part B of the question. Part B, it is telling us that a binary operator is defined by whatever that symbol is, and it says that it is defined on a set of positive real numbers where y, whatever x is equal to y squared plus x squared plus 2y plus x minus 5xy. Solve 2 phi x equals 0. I'm going to call it phi, even though it's not phi. I don't know what that symbol is. So 2 circle cross 0. 2 circle cross x is equal to 0. This is what we're solving. Now this means that looking at the equation, anywhere we see y, we're going to replace with 2. So what we're going to get is, replacing y with 2, y squared is 4 plus x squared. Anywhere we see y, we replace with 2, so then 2y becomes 2 times 2, which is 4, plus x minus 5xy, and we know anywhere where we see y, replace y with 2. So 5 times 2 is 10, so it's really minus 10x. And this is equal to 0. All right, so now that's it. Now, of course, this looks like it's going to lead to a quadratic. So what we have is x squared. Now, where you have x and minus 10x, that just become minus 9x plus 8, and that's equal to 0. So you have x squared minus 9x plus 8 is equal to 0. So you can go ahead and factorize it and equate it to 0. Equating it to 0, it's going to be x, 8, and 1. Signs are the same and both of them is negative. So minus, minus. So x is equal to 1 or x is equal to 8. That's the solution for this question. Nice and easy. X equal 1 or x is equal to 8. Now let's move right along. Now, the next part of the question says, use mathematical induction to prove that 5 to the n plus 3 is divisible by 2. So part C. First thing I like to do is call the statement Pn or Sn or something. So I'm going to let Pn be the statement 5 to the n plus 3, and they said that it is divisible by 2. So I'm going to write that 5 to the n plus 3 is equal to some 2 to the x, where x is an integer. X has to be an integer because it is divisibility, where x is an integer. All right, so let's knock out this question real quick and fast. So the first step that we know is that when you're doing proof by induction, you start with when n is equal to 1. So when n is equal to 1, what we're going to get is 5 to the 1 plus 3, and 5 to the 1 plus 3 is equal to, yes, we know it's 8, but look how I'm going to write 8. I'm going to write it as 2 times 4. So yes, and so hence P1 is true. So we can conclude P1 is true. We call the statement Pn, so P1 is true. Nice. Now that we show that P1 is true, let's know for n equal k. For n equal k, what we're going to have is 5 to the k plus 3 is equal to, let's call it 2 to the q, or 2 times q, where q is of course an integer. Where q is an integer. Nice. Good. Now, next thing is that we need to assume that n equal k is true. So we're going to assume n equal k is true. So now that we assume n equal k is true, you only need to look at the final step now, and the final step is to prove that n equal k plus 1 is true if n equal k is true. So now when n is equal to k plus 1, n equal k plus 1, what we're going to get is 5 to the k plus 1 plus 3. All right. Now, I'm going to go back to over here. Well, assuming this one is true, but if I was to make 5 to the k the subject, right? If I were to make 5 to the k the subject, I would say that 5 to the k is equal to 2q minus 3. Agreed? Yes, yes. So now what we're going to do now is, instead of writing 5 to the k plus 1, I'm going to break that down as 5 times 5 to the k plus 3. That's how I'm going to break it down. But then, of course, 5 to the k is 2q minus 3. So what I'm going to get is 5 times 5 to the k, and 5 to the k, which is 2q minus 3, plus 3. Nice and easy. After you do this now, you just expand through this bracket, and what you're getting is 5 times 2q is 10q, minus 5 times 3 is 15, plus 3. And so what this works out to be is 10q minus 12. This works out to be 10q minus 12. But we wanted to show that's divisible by 2. So we can go ahead and factor out 2. You factor out 2, you're going to get 5q minus 6. So hence, it works out to be, you can call all of this like a j. If you call all of this like a j, it works out to be 2j. And so hence, it is divisible by 2. Alright, and so hence, or you can say therefore, pk plus 1 is true. pk plus 1 is true. Now, anytime you write that pk plus 1 is true, you don't finish it. You always write a conclusion when you're doing mathematical induction. So you're going to write hence, by principles of mathematical induction, by PMI, we can say that the statement Pn is true for all n an element of natural numbers. It's true for all natural numbers. Nice and easy, soft. That takes care of the induction part. All right, now we reach part D. Part D, it says, f of x is x cubed minus 9x squared plus px plus 16. All right, so you write that down. X cubed minus 9x squared plus px plus 16. And then what they want us to show that p equals 6 given that x plus 1 is a factor. If x plus 1 is a factor, then what they're telling us is that f of 1 is equal to 0. And if f of 1 is equal to 0, that implies let us replace x with 1 to get 1 cubed, which is 1, minus 9 times 1, which is 9, plus p times 1, which is p, plus 16, that's equal to 0. And if this is equal to 0, then 1 minus 9 plus 16, that is 1 minus 9. 1 minus 9. Or they say x plus 1 is a factor, so f of minus 1 is 0. My apologies. So this should be minus 1. This should be minus 9. This should be minus p. See, I'm giving it away. And so minus 1 minus 9 is minus 10 plus 16. That works out to be 6. And so 6 minus p is 0. And if 6 minus p is 0, then p is of course 6. So that takes care of part 1. Let's see what else them say. They said to factorize f of x completely. To factorize f of x completely, it's best to do polynomial division. So let's go ahead and do our polynomial division. Given that we already know one factor is x plus 1, we can divide it by x plus 1. All right, so let's do the polynomial division. We're going to divide it by x plus 1. Dividing f of x by x plus 1, we know that f of x is x cubed minus 9x squared plus px, where p is 6, so it's really plus 6x plus 16. Nice. So let's do this division now. We're going to say x into x cubed goes x squared. Then x squared times x is x cubed. X squared times 1 is just plus x squared. And then we're going to subtract them. Then we subtract. After we subtract now, x cubed minus x cubed, that gone. Minus 9x squared minus x squared, that becomes minus 10x squared plus 6x. Nice and easy. Then we're going to say x into minus 10x squared, that's now minus 10x. All right, and then x times minus 10x, that's minus 10x squared. Then you have minus 10x times 1, which is minus 10x. We're going to subtract them. When you subtract them, minus and minus give you plus, so you get 16x. And then you bring down the plus 16. Then x into 16x plus 16, that leaves plus 16. And then 16 times x is 16x. And then 16 times 1 is 16. All right, plus 16. And then you subtract them. Once you go ahead and you subtract them and get 0, you're nice. So now what we're getting for f of x is, to factorize it, we can clearly see that f of x is working out to be equal to x plus 1 times x squared minus 10x plus 16. So let's write down this quadratic factor of x squared minus 10x plus 16. And then you can factorize that quadratic expression there. All right. And so finally, when we completely factorize f of x, we can see that f of x is x plus 1 multiplied by, this looks like signs are the same, both of them negative. So it looks like x minus 2 times x minus 8. That's how we factorize it. Nice and easy, soft. Okay, so we've completely factorized f of x. So this is part 2. Part 3 says hence solve f of x equals 0. Solving f of x equals 0, that means you're going to be solving for the roots. And it says hence, that means you should just use the factors that you have. So solving f of x equals 0 is very simple. You're just going to get, I'm just going to write down the solution. Solving this equals 0. This is how we're solving. We're solving x plus 1 times x minus 2 times x minus 8 is equal to 0. This is what we're solving. And if that's what we're solving, we're going to get x equal -1, or x is equal to 2, or x is equal to 8. That's how we solve f of x. That's part 3. That gives you 3 marks to do nothing. What am so nice? And that takes care of question 1. Nice and easy. Soft. Let's go to question 2. Question 2 gives us a set. It said the set A is defined by x is an element of real numbers, where x is greater than or equal to 1. And it says a function, it maps the domain A onto the set of real numbers such that f of x is x squared minus x. Show that f is 1 to 1. Now there are many ways you can do this, but I'm going to take the graphical approach. That is what we're going to take today. So taking the graphical approach, f of x is x squared minus x. First thing I'm going to do is complete the square. To complete the square, I half this, so I'm going to get x minus 1 all square subtract 1. That's how I complete the square. And I know that this is for the domain where x is greater than or equal to 1. All right, and so if this is the curve, then this is what happened. I'm going to draw a quadratic curve. And the minimum point is 1, negative 1. That's what I have. The minimum point is 1, negative 1. But then remember, for the domain of the function, so let me put in the x and y axis first. Let's use blue. X is 1, so x being 0 is here. All right, so don't want it to go too far down. Just sketching the axis. All right, so this is valid for the x and the y axis. Not quite valid. I'm going to re-sketch the curve a little better. Yeah, this look like it now. Now this is the curve, right? This is the curve of f of x, but them tell you that the function is defined for x greater than or equal to 1. So we can remove this part of the curve, and so this is all we have left back. So if this is all we have left back, what we can then do is do a horizontal line test. So we're going to do a horizontal line test. So doing a horizontal line test, we notice that it only have 1 point of intersection. So writing it down, horizontal line test only detects 1 point of intersection. All right. So the horizontal line test is only detecting 1 point of intersection. If the horizontal line test, as you can see, only detect 1 point of intersection, hence f is 1 to 1. So that's how you can show this. You can do it in different other ways, but this is the easy way to do it. All right, nice. So that's 7 marks. That's part A. Now let's look at part B. Part B says f of x is defined as 3x plus 2 and g of x is e to the 2x. Find f inverse and g inverse. So first thing now is In order to find inverse, you have to interchange x and y. So x is actually 3 f inverse plus 2. And then you make f inverse but the subject. So what we're going to get is f inverse of x. If I transpose and make f inverse the subject, I will get x minus 2 over 3. All right, so that takes care of part. That takes care of that part. Now for g inverse, now they tell us that g of x is e to the 2x, and so I'm going to replace x and write that x is equal to e times 2 times g inverse. So I'm going to take ln of both sides to get that ln x is equal to the log e. Log of e is 1. Log of e is 1, and so I just get 2 times g inverse. Then I divide through by 2 to get that g inverse of x. G inverse of x is working out to be dividing through by 2. I will get a half ln x. So that's g inverse. Nice. Now it says find fg of x. Fg of x is putting fg of x is putting g of x into f. Let's do that. Fg of x. Fg of x is equal to putting g of x into f. So it becomes 3 times g of x, where g of x is e to the 2x, plus 2. So that's fg of x. Nice and easy. Now it says show that fg inverse is the same as g inverse f inverse. So we need to find the inverse of this function. All right, so let's call fg inverse y for now. So interchanging them, we would get that x is equal to 3y plus 2. And you make y the subject. Wait, why would I do that? My apologies here. All right. So call fg of x, y, they interchange x and y. So you're gonna write that x is equal to 3 times e to the 2y plus 2, where I'm calling y f inverse g inverse. All right. So I need to make y the subject, so I subtract 2 from both sides, and then I divide through by 3. All right. And that's going to give me e to the 2y. That's giving me e to the 2y. Since I'm getting e to the 2y, I'm going to take ln of both sides. And so what that works out to be is, from what I'm seeing, fg inverse is going to be equal to, I take the log of both sides, and then I divide by 2. So fg inverse is working out to be, shouldn't have skipped that step, but just for the space, it's a half ln x minus 2 over 3. Nice and easy. That's fg inverse. Now, of course, we need to find what is fg inverse f inverse. So we need to put f inverse into g. So let's put f inverse into g. So putting f inverse into g. So g inverse f inverse, that's going to be equal to putting f inverse into g inverse. So put x minus 2 over 3 into g inverse, and we're going to get a half. Voila, it's the same already. It's the same. So it's a half Here is G inverse and here is F inverse. F inverse into G inverse, you get a half ln, replace X with F inverse, and so it's a half ln X minus 2 over 3. All right. From these two, I'm going to connect them right here. From these two, clearly we can conclude hence, or you can say therefore, FG inverse, clearly we can say that FG inverse is the same as G inverse F inverse. That takes care of this part of the question. Nice and easy, soft. Part C. Part C says to solve 3x squared plus 4x plus 1 less than or equal to 5. So we have a quadratic inequality. Baby maths, add maths, C-set maths, primary school maths. So easy. X of the primary school maths is just so easy. So we have 3x squared plus 4x, 3x squared plus 4x plus 1, and that is less than or equal to 5. Right, so 3x squared plus 4x plus 1, that's less than or equal to 5. Now that this is less than or equal to 5, what do we do? Since this is less than or equal to 5, all we have to do is, okay, first things first, you subtract 5 from both sides. Subtracting 5 from both sides, you're going to get 3x squared plus 4x. Subtract 5 from both sides, 1 minus 5 is minus 4, and that is less than or equal to 0. Then we're going to factorize it, and that's less than or equal to 0. For 3x squared, it has to be 3x and x. Signs are different. The bigger one associated gets the positive. That looks like 2 here and 2 here. The plus goes here and the minus goes here. Let's check it out. 3x times x is 3x squared. 6x minus 2x is 4x, so we're fine. So you have 3x minus 2 and x plus 2. So what I want you to do is sketch a graph to see what is happening. So the roots would be, that looks like minus 2, and 3x minus 2 would be 2 over 3. Now, the portion of the graph they want is when the curve is less than or equal to 0. So that's down here. So the solution is going to be x is such that x is going to be less than or equal to 2 over 3, but x is definitely greater than or equal to minus 2. So that's the solution set for x. Nice and easy, soft. Nice. Now, let's continue. It wants us to solve for the modulus of x plus 2 is equal to 3x plus 5. It wants us to solve that the modulus of x plus 2 and that's equal to 3x plus 5. If the modulus of x plus 2 is equal to 3x plus 5, then there are two possible solutions. The two possible solution is, that means x plus 2 is equal to the negative of 3x plus 5, or x plus 2 is equal to the positive of 3x plus 5. You don't need to be squaring both sides. Think about it. If you had just the modulus of x equal 1, don't the only answer would have been minus 1 or plus 1? Yeah. So it's just minus this or the plus of it. Nice and easy. That makes sense. So now all we need to do is solve for x. So if x plus 2 is equal to this, then we're getting x plus 2 is equal to negative 3x minus 5, or we're getting x plus 2. We can simplify this one already. Bring over the x over here and bring over 5 over here. We get 2 minus 5 is equal to 3x minus x. So going down, we can bring over 3x over here. We get 4x is equal to, subtract the 2 over here. We're going to get minus 7. And we're getting over here, 2 minus 5 is minus 3, and 3x minus x is 2x. So what we're getting then is, solving both of these, we're getting x is equal to negative 7 over 4, or you're getting x is equal to negative 3 over 2. Now, anytime you're doing modulus question, you need to check the solution. So try it. So just to test it out, negative 7 over 2 plus 2. And when I add them, I get 1.5. So let me see, 3 times negative 7 over 4 plus 5. Negative 7 over 4 plus 2. And 3 times negative 7 over 4 plus 5. And then minus 3 over 2 plus 2 is a half. And 3 times minus 3 over 2 plus 5 is a half. This one is not valid. This one, not valid. This one is not valid. All right, and you may ask, so sir, why is this one not valid? This one is not valid because if you put in, you do the test, when you test the left-hand side, when you put in minus 7 over 4, you're going to get minus 7 over 4 plus 2. You're going to get a quarter. So you're going to get a quarter. Let me write 1 over 4 on the left-hand side. But the right-hand side that you're going to get is when you put in 3 times, minus 7 over 4 plus 5, you're going to get a negative value. You're going to get negative a quarter. So that's why this one is not valid. They're not the same. They are not the same. Since they're not the same, then that can't work. All right, so that takes care of question 2. Since question 2 is finished, we're finished with module 1. Nice. Nice. Now that we finish module 1, we can go to module 2.